sir.
Okay, welcome again to our power plant engineering class. So, in the last class, we have covered the wind turbine based power plant, right? So, I think today we can cover another type of power plant that is called uh, solar power plant. Okay, so can you see my screen right now?
Yes, sir.
Okay, thank you. So, we can start then. Okay, so today is our lecture 8 that is called solar based power plant. So we will cover some of the solar based power plant, and first of all we need to know about some parameters related to the sun and the solar power. Then we will cover the different types of conversion method from solar energy to electrical energy, and then we will discuss thoroughly about those type of power plant. Okay, so before going to that, we need to know about some uh, detail about solar energy. So it is one kind of non-conventional energy, so conventional energy sources has some disadvantages, as we discussed in the first class, that we have gas, but the shortage of gas can hamper our overall power generation, right? Also, if we have uh, heavy fuel oil, uh, that will be the rising concern about greenhouse effect or the climate changes, right? So, considering those factors, non-conventional energy source like wind, uh, biomass, or hydroelectric power, or solar power, even tidal or wave-based power, those can help us to reduce carbon dioxide emission, and also that will create a clean environment for all of us, right? So that is the main concern to use renewable oriented power based power sources. So in our country, you can see in different newses and articles, like uh, some of the big companies, they actually try to implement solar photovoltaic oriented power plant, right? And some of the names of those power plants. Recently, government took some initiatives to utilize the rooftop space of the industry to utilize those type of solar panels and generate their own energy. So here, in our country, we are uh, mostly known to those solar photovoltaic system and solar photovoltaic system based power plant. But in the world, uh, most of the countries actually, they utilize sun energy to produce heat, and they utilize that heat to run turbine, and that's how they can create energy, that they can harness electric energy. But in our country, we are mostly involved, and we are mostly known to the solar photovoltaic oriented power plant or power generation process. But this solar energy can provide you two types of conversion process. Number one is solar thermal, and number two is solar photovoltaic. We will discuss solar thermal and solar photovoltaic separately. So we can discuss today. Number one, solar thermal. The conversion process, and number two, solar photovoltaic. Okay.
Rules are made to be broken.
So
Or people.
so before going to the detail of solar thermal and solar photovoltaic, we will discuss on solar radiation first. Okay. So what is solar radiation? Any idea about solar radiation? Anyone? What is solar radiation?
So the amount of sunlight that is that we are getting from the sun, the amount of photon in that sunlight, I sir.
Okay. Anyone? Any other suggestion? What is solar radiation? Any guess?
Sir, the power sent by the sun, energy
Okay,
emitted by the sun.
here two terms came from your side. Number one is someone called power, right? And another someone
Sir,
called
energy,
light
sir.
or
Power
light
energy, yes.
energy. Yeah,
Yes.
yes. So two terms uh, here. So what is power and what is energy? You need to understand these two terms first to separate the terms irradiation and irradiance. Okay, so these two terms is totally different. Okay, number one, the power, that means suppose if you have the earth surface, this is your sun. Okay, it has some energy, the temperature it has, and the sunlight or the energy falls to the earth's surface. Suppose this earth surface is 1 meter square earth surface. The amount of power is coming from the sun, suppose that is represented by watt. Okay, so the density of that power or the rate of energy you are receiving into that surface, that is called your irradiance. Okay, the irradiance have the unit which is called watt per meter square. So per meter square area you are getting some 100 or 1000 watt power, that is called your irradiance. Okay, so power actually represents the term irradiance. Okay, so another point of view, solar uh, energy, that means the sun energy you are getting. Suppose you have the power, you multiply it with the time, that means P into T, that will provide you energy. So the unit should be then watt hour per meter square. Okay, so that is called your solar energy. Is it clear?
Yes, sir.
So one terminology is irradiation and another terminology is the energy, the sun energy you are getting. Suppose you are getting the energy per day, watt hour per meter square per day, then you need to write it per day. If it is month, per month. If it is year, per year. If it is per hour, you need to write per hour. So this is our energy term and this is our power term. Okay, we can say the irradiation, that is called our power, watt per meter square, and if we multiply it with time, with hour, with day, with month, then you are getting the energy or cumulative energy. Okay, so we need to understand these two terms first. Okay, so the sun energy that is coming from the sun to the earth's surface, we can get the irradiation then. So we can separate that irradiation from different parts, right? So how these irradiation is different. So if you consider one sun, particular sun, the direct sunlight is coming from the sun, which is called, we can say, direct irradiation, okay, or direct radiation, whatever. Direct irradiation that is coming directly from the sun. We can say that direct irradiation, the angle of the direct irradiation considering 90 degree, okay, that means we can say like that sunlight falls to the ground directly. Suppose we have our surface, that is the sunlight coming directly, that is our direct irradiation. Suppose in some portion there are some cloud here, so some sunlight can be scattered before coming to the earth's surface, right? That scattering can provide you some sunlight also. That sunlight may be 20% of the direct irradiation, maybe 10 to 20% of direct irradiation. So that is called diffusion or diffused irradiation. Okay. So one is direct irradiation, another is diffused irradiation, and some of the sunlight is reflected components. Okay, so suppose you have some building here, or some types of material is laying on the ground, so that can also reflect back some irradiation to the surface of the earth. That is called reflected irradiation, or sometimes they can be renamed as albedo. Okay? Or albedo. Okay, so we can get three types of irradiation: direct irradiation, or we can say it beam irradiation, which is 90 degree in angle. There are some cloud, the sunlight can be scattered, and some portion can reach through the earth. That is called diffused irradiation, which can be 15 to 20% of the direct sunlight. And another part is ground or reflected irradiation, which depends on different surface of the different materials. Okay, so that is called our reflected irradiation. So we can say like these three types of irradiation can sum up, and you are getting the total irradiation which is falling onto that 1 meter square surface. Suppose you are taking 1 meter square surface area, so the amount of power can be termed as watt per meter square. That is called total irradiation. And the energy, if you consider the time, you are getting the energy which can be named as watt hour per meter square for 1 hour. If it is day, if it is month, you can just convert it to the day and month. So anyway, we can write it like the total summation. Suppose I represent the direct is IDIR, I represent the diffused is I diffusion, and represent the albedo or reflected I reflected. That three terms, actually it is called global irradiation. Okay, global horizontal irradiation, or I, we can say G, we can say I global horizontal irradiation. Okay, global, as the surface is horizontal, that is called global horizontal irradiation. Is it clear to you? Any question?
No, sir.
So what about the then daily plot for one particular scenario of solar irradiation? Okay, we can just plot it. There's several equation sets to mathematically show how actually you can describe the solar irradiation. We are not going through the detail of those theory as it is not our concern for this course, but we need to know the daily pattern, daily plot pattern to understand how irradiation actually changes. So suppose it is our hour for particular day, and this axis is irradiation axis, which is power. That means watt per meter square. That is it represents power. Okay, so how it varies? Suppose in the morning at 6 o'clock, sun rises, but you know, for a particular specific east to west, sun moves from east side to west side. Okay, this is our sun. So you see, for this particular flat plate, the sunlight here does not reach to the flat surface, as the light amount of energy is pretty less. That means you are getting less power. So at a 6 o'clock, maybe the power amount is very less. But when it is 7, it reaches there, and you are getting some portion of sun energy, right? So maybe the sun energy or the power is increasing. At 8 o'clock, maybe the sun is on different angle, so you're getting more energy. So that's how your power is increasing. And like that, 9, 10, 11, 12. At 12 o'clock, the sun should be on top of your head, on top of your surface. And that surface can get direct 90% direct irradiation from that sun. That is called a direct irradiation, right? Also, it will get the diffused and reflected irradiation. So that provides you the highest amount of irradiation at 12 o'clock if the sky is cloudless, okay, non-cloudy day. So that represents you are getting highest amount of power at 12 o'clock. And like that, if you draw the complete plot, suppose 1 o'clock, 2, 3, 4, 5, another 6. That means the sun goes down after 6, right? One is AM, another is PM. So like that, you can again plot the other half, and you are getting some this type of parabolic plot, and that plot is called solar irradiation, daily solar irradiation plot. Okay. So why it is necessary? Because based on that, you can understand in which portion you are getting the maximum energy. Okay. Also, the amount of total daily energy you can calculate from this daily solar irradiation plot. How? Suppose you are trying to calculate the energy. What should we do? We just need to calculate the time with that power, right? Suppose you have power 100 watt per meter square. You have consider 1 hour time. So 100 meters watt per meter square into 1 hour, you are getting 100, right? Suppose this point provides you 100, but in the next point you spend at least 2 hours. If previously it was 100, now suppose this is 200. 200 into another 1 hour. Previously 100, now it is 200. That means you are getting 300 in this point. So this point should be 300. So in like that, you can just plot, and you are getting a very incremental type of plot. That is your energy plot. Okay, suppose it starts from here and you're getting this point, and maybe you are getting 5.5 kilowatt hour per meter square. That is your total daily energy. Okay. You understand the thing? Any question?
No, sir.
স্যার পাওয়ারের ক্ষেত্রে কি স্যার পদটা সেম হবে?
No, no. For the power, it is on top. This is the power plot, okay? The irradiation, that is your power. And for the energy, you are getting cumulative summation of hourly energy, and you are getting the highest energy at the end. This is your total daily cumulative solar energy, maybe 5.5, whatever the value is. I'm just providing an example, okay?
Yes, sir. Thank you, sir.
So now, as we know the irradiation plot and the energy plot, it seems like during the mid time of the day, suppose after 10 o'clock to 2 or 3 o'clock, these 4 or 5 hours, you are getting the maximum amount of energy, right? Almost. And this portion shows you the very high amount of power. So if we have the solar power plant, in this region, the power plant will get maximum amount of energy. It can harness maximum amount of solar energy, okay? But in previous or the after or before that time period, the amount of power is very less, and maybe your solar power plant will not get that high amount of power. So typically, a solar power plant is designed to work or to harness maximum energy during that 4 or 5 hours daily. Okay, and other time is considering the extra. Maybe you are not getting that much of that amount of power from those time after 3 or before 10 o'clock. You are not getting that high amount of power. So these 4 or 5 hours, they are called operating hours, and mostly power plant is designed considering that time period. Okay. So now we can go to the solar thermal power plant. And what about the solar thermal power plant types? Solar thermal power plants, that means you need to get the sun power to the solar thermal collector plate, and that collector plate transfers the heat energy to the water. Water vaporizes, temperature increases, it will produce steam, and you need to collect that steam and run it to the through the turbine, and you will get some electrical energy. Okay, so that a solar thermal power plant can be two types. One is flat plate collector, and another is concentrating collector. That means you need to collect the sunlight in a concentrating way. That means whole light will be concentrated in one point. Okay, so that is called concentrating collector. So there are several types of concentrating collector. I can provide the types. Number one is parabolic trough type. Number two, maybe Fresnel lens type or linear Fresnel. number 3, disk type, we can say. You know the dish antenna, disk or dish type, whatever. And another is central receiver type, okay? Heliostat or central receiver. So that means you need some mirror to concentrate the light in one point. That is the main objective. So if I want to show you some figure of those types of concentrator, I'm just sharing my screen again. So I hope it is visible to you. You see there are 4 types of concentrating type collectors. Solar light falls to the parabolic trough type of arrangement of the mirror, that is called reflector. We can say mirror, as reflectors are pretty much glass made. And also you see there are some tube on top of those reflectors. That means the reflector is designed such a way they can vary their angle on time to time based on the sun position. Okay, so this is called single axis tracking. And that absorber pipe that can absorb the sunlight as the sunlight falls on top of the trough, and then it reflects back to the pipe. And that pipe is pretty much transparent material, maybe transparent pipe, and it can absorb the heat in between maybe water flows. So that is called absorber tube, and then that can get the heat, temperature rises and flows to the another pipe. So like that, if you want to concentrate high amount of energy light in a certain point, that is called receiver type of reflector. So that dish type things, all the light is concentrated in one particular point, and that point can get high amount of heat, and it transfer the heat to the fluid, and fluid can get the heat and rise their temperature. And also this is another absorber Fresnel type, linear Fresnel. So there are some curved mirrors, and in central tower that can receive the whole amount of light, and this is called solar tower based or central receiver. So circularly, so many solar panel type of mirrors set up there, and sun reflects back the whole light in a one particular solar tower. That tower should have big drum. That drum contains maybe water or liquid, and that can start vaporizes and produce steam. That is the idea. So there are 4 types of concentrating solar thermal receiver. Okay, number 1 is our parabolic trough. Number 2 is dish type or disc type. Number 3 is Fresnel lens type, and number 4 is central receiver type. Okay. So now we can move to our lecture again. So why does these type of collector is required? Because this type of collector actually based on mirror that can directs the sunlight to a certain point, and that certain point can have the fluid, and you can heat up the fluid very well. So this is the main objective. So how does solar thermal power plants look like? So the block diagram should how the block diagram looks like. So we can draw a figure so that we can understand how does it work. Okay, so I'm going to provide you one basic block diagram of solar thermal power plants. So first of all, for that solar thermal power plants, you need suppose I am taking parabolic trough. Number 1 concentrating type of solar plants here, for our study. So they are looking like this. So in between, I can draw our pipeline. This is our pipe. So suppose this is in point, and light from the sun falls on top of the trough and then reflects back to the pipe, and that pipe contains the water, suppose. So then that heated water flows to a container and it exchanges the heat. Okay, suppose this is our container. It exchanges the heat. So there should have two tanks. One is called hot tank, and another is called cold tank. Okay, so the hot water comes here, exchange the heat, and this is our storage tanks. One is cold tank and another is hot tank. That means the water exchange the heat to the cold water, and then cold water goes and stores into the hot tank. Okay, and after that, that water can gets cool and then again is connected to this pipe. Okay, here we can get cool water. This is hot water. This is heat exchanger. Okay, then we can use that hot water also to produce our steam. So this hot water also can go to the main reheater. So this is our main reheater. So here it can be connected with our reheater. So we need a turbine. Suppose the turbine should be two types. One is low pressure turbine, another is high pressure turbine. So another, we need a superheater also. We need vaporizer. We need economizer. Okay, I'll write the name then after drawing. So first one is our superheater. Second one is our vaporizer. And third one is our economizer. So it is connected with this tank. And after that, we can connect it directly through a pump. So now on top we have our reheater. This is a reheater. So this is called reheater. Okay. And then the turbine is connected to the generator. This is turbine. This one is LP, this one is HP, high pressure and low pressure turbine. And after that, the turbine releases the steam. That means the condensated steam. It requires more condensation and then turns into water. So we need one condenser here, and it is connected again to the economizer. And we need cooling tower here. So I think that's all. So we need a pump here. This is called feed water pump. This is called a high temperature fluid pump. Okay. So how does the whole thing actually works? Like we have hot water, and hot water is coming from this point, and it will require to superheat. So this junction will provide one path to flow the heated water here, and it comes to this point and get superheated. That is called superheater here. And after superheated, the fluid in between the point, in between that tube, this comes to that high pressure turbine and rotates that turbine. Okay. And after rotating the high pressure turbine, maybe it loses some temperature, some heat content, then it requires some reheated point. So that's why that less temperature steam comes to the reheater and reheated again and flows to the low pressure turbine and rotates the low pressure turbine. And after that, it releases the steam here, and the steam gets condensated and cools down and moves through the feed water pump to the economizer. Economizer provides so the economizer is connected directly through this point. Okay, so I need to draw it somehow again. This one. So economizer, and then that economizer helps to heated the water again, and it flows towards the vaporizer. Vaporizer vaporizes the steam. That means the water turns into steam. Then that steam will go to the superheater again and get superheated and again go to the turbine. That means this cycle circulates through the turbine separately. This cycle, okay, the double arrow cycle, whole cycle is only for turbine. So the turbine has some fluid or the water. So this is this circulates through the whole turbine side. But the one arrow, the single arrow, that is coming from the solar concentrator plate. The plate reflects the light to the tube, and that tube has the water, and it gets heated coming to the hot water tank, and we can just use the heat exchanger to exchange the heat to the hot tank. This is our reserve tank. We can utilize that hot water when we require, and also we can directly use that hot water to the reheater, right? We can use that water into the reheater to reheat our steam. Also, we can connect it to the outgoing pipe as well. And also we can use that superheater, that superheated content. So with that point, with that terminal, so the hot water coming in superheater exchange the heat. Again, additional the more heat content it has, so you need to add it into the vaporizer section. It will help you to vaporize the condensated water. Also, you can use the remained thermal heat content into the economizer to preheat the overall water. Okay, so that means you are getting heat content from the solar collector. You just exchange that heat content in 4 places: reheater, in superheater, in vaporizer, and in economizer. And you have water in for using into the turbine. That water can gets the heat content in superheater, in vaporizer, in economizer, or in reheater, and circulates through the turbine part. Okay, so we have two separate flow line for water, two separate types of flow line here. One, water is coming from the solar concentrator. It can get heated. That heat is exchanged in our 4-point reheater, superheater, vaporizer, and economizer, and it has separate flow line for water. That particular water is used only for running the turbine. That means you need to produce the steam and you need to run the turbine, and you are getting electrical output. So this is the main flow diagram for solar thermal power plant. So if you have any question, you can ask me for more details. So any question?
স্যার রিহিটার থেকে স্যার দুই দিকে স্যার যাইতেছে স্যার আর কি মানে হাই প্রেসার টারবাইন থেকে স্যার
Yes. From the high pressure turbine, suppose you have one turbine, you are getting the steam. Here is your steam, suppose. Okay, from this point, turbine rotates, but after that, it may lose some heat content, right? You need to reheat it before entering into the low pressure turbine sector. So that we need reheater in between the two turbine. You know it from the steam turbine power plant. So that's why we are using reheater here. So this water or steam content it flows through this double arrow line, and it collects the heat from where? Somewhere you need to collect the heat. That's why you need that hot water you are collecting from the concentrating parabolic solar collector. So that water has heat. It can receive the heat from that water in this reheater. And reheater is actually a heat exchanger, right? So that water has heat, you have less heat. So you are collecting the heat content from that water through this pipe, and again you are gaining the temperature which is required to run the low pressure turbine. That's how it works. Okay.
So then does it mean that from the reheater it goes to the high temperature fluid pump, then it goes back to the reheater again, then to the low pressure turbine, sir? Because there is a line that going down the high pressure fluid pump, sir, from the high
Yes,
pressure.
high pressure fluid. This means the reheater rejects heat here, right? This there is a junction here. So you have some pipes and tubes or valves here. You are connecting some pipes with the reheater, connecting some pipes with the superheater. Also, you are connecting it to the vaporizer and the economizer. So after rejecting heat in the reheater, that water should be less heated, right? So you can collect it again here in that high temperature by this high temperature fluid pump to reach it to the main line, so that you can again collect heat from the sun. To understand my point, so this point is cool water, I can say, to understand better. So these are cool water, cool, cool. So after flows through the concentrator, you are getting warm, or it should not be warm, it should be hot water. You understand?
Yes, sir. Thank you.
Yes. So again, this valve, I'm just pointing the valve again. This has another connection which flows to the superheater. Superheater is also another type of heat exchanger. That means you have heated or vaporized steam. You need to superheat that steam. So we can say vaporizer produces steam. So steam is flowing in the upward direction. You need to ensure that steam does not have any water content. So again, you reheat it. That is your superheater. So suppose I am just considering that from this valve, the temperature should be high here. The water temperature should be high here. So it can superheat the vapor. After that, the temperature will be low and it comes to the vaporizer. So to vaporize the water, you need only 100 degrees centigrade, right? That makes sense. So maybe the temperature is medium here. And after that, you need to, suppose economizer means to preheat. We can say like this is preheater. This is our preheater. So maybe you need 50 degrees centigrade here. So we can say like the temperature is low here. That means from that point, from that junction, water temperature is coming, very high temperature, maybe 300 degree, suppose, and it rejects heat in the superheater to make the steam more or less water content based steam. So after superheating, it reduces or exchanges heat and then comes to the vaporizer. And vaporizer requires only 100 degree temperature to vaporize the water, right? Maybe the temperature is 100 degree here, and after that,
আবার কি করে না
after that,
যাও
remaining content will go to the economizer,
আজকে
right?
শেষ
So that is our maybe 50 degree.
সেন্টিগ্রেড
So any concern about this topic? Rakib, do you want to say anything?
নো স্যার
Okay. So this block diagram, I will provide you the slide as well. It is also in the slide. You can just go through the slide, but the detail is not written there. So I just tries to provide you the detail. So if you have any confusion, you can go through that drawing with the help of PPT slide. Okay. So that's all from our solar thermal power plant. Now we can move to the solar photovoltaic based power plant. Okay. The photovoltaic, actually, we have our solar cells. So we can use the solar cells to convert the sun energy to the electrical energy. So we are not going to cover different solar photovoltaic cells or some other components. Rather, we will cover only the power plant part. Okay. So we can understand that if I want to use that solar photovoltaic to produce energy for my personal use, that is called off-grid solar photovoltaic power plant, right? And if I want to send the energy to the grid line, that is called on-grid photovoltaic power plant. So to cover that part, we need to know the basic block diagrams for on-grid and off-grid solar photovoltaic power plant. So I will show you first the standalone or off-grid type of power plant. Okay, so first standalone. Standalone means the off-grid solar power plant. That means you don't need to connect it to the grid. So for this you need solar panels. So before that, if you have one particular solar cells, this is our cell, it can produce maybe 0.5 volt. So if you connect the cells in a series form, you can get higher amount of voltage. Suppose we have 4 cells, what would be the voltage then? Each has 0.5 volt, then you are getting
2 volts.
2 volt here, right? And if I have 2 branches, suppose each branch has 1 ampere current. So if you have 2 branches, then the current would be
2 amperes. Sir.
2 amp, right? So like that, if you just arrange it in a particular module form, then that is called solar module. So we have cells in a particular module. Okay, and if you arrange those modules in a way that, suppose this is your one particular module, this is another module, maybe this module has maybe 17 volt and 1 amp. This module has also 17 volt, 1 amp, connecting 3 different modules, 3 same type of modules here. So what would be the voltage then? The voltage would be 51 volt, right? And you are getting 1 amp from this connection. So this type of connection is called array. So we have 3 things. Number 1, we have cells. Number 2, if you arrange some cells in a module, that is called solar PV module. And after connecting several modules, you are getting solar panel array. Okay. So to understand grid type of or off-grid type of solar photovoltaic plant, you need to know that we are using solar panel array rather using modules. Okay, in modules, maybe you can use in your house, maybe some modules you can use that is off-grid. Maybe it is possible in off-grid that you are using panels or you are using array, but in on-grid type, mostly PV panels are not using PV panels, they are using mostly array. That means several PV modules should be there. Maybe if you have very high amount of power based PV panel, you can use one single panel also. Okay, so what would be the block diagram then? Suppose we have solar panel arrays, maybe here. Okay. So we can connect it like that, a series or parallel connection, whatever you want. Then you need a charge controller, CC, that means charge controller. So you are getting DC from that PV, and that charge controller, after charge controller, you are getting suppose DC voltage. So you can use those DC voltage to store that energy. Okay, so you can use one particular battery here. So you can use battery. So you are storing the battery. So suppose the battery can be in 12 or 48 volt, different pack should be there. And also you can use it in our DC load. Okay, we have DC load, suppose fan, light, whatever, you can connect it directly to the DC load. Okay, so suppose I am considering it a light, and after that, if you want, you can use that power to invert, right? To invert it, and if you want to invert it, you need an inverter. Okay, so suppose I need an inverter. So this is our inverter, and that inverter provides you AC output. Suppose you need some switch here to connect it with the AC load whenever you want. Okay, maybe this is our fan or whatever. You understand my basic diagram? So we have PV panel, you're getting DC. The charge controller helps you to control the charge and voltage for particular charging into the battery. A battery may have 12 or 48 volt package, and you can connect that battery or the output with the DC load to run the load. Maybe there are some switches and fuses, whatever. And after that, if you want, sometimes you can use it to convert it into the AC, and you can connect it with the AC load, right? So this is our off-grid type of or standalone type of power plant, PV power plant. Okay, so we have another type that is called on-grid. So for that, maybe we need several arrays. I'm just considering 2 panels here. So we have the DC again, and after that, you need to connect it with the inverter, right? You need to invert it, so don't need any charge controller or something like that. They connect it to the inverter. The inverter will provide you the AC output, right? And then you can connect it with the AC load as well. So before that, as you want to send it to the grid, you need some switch here to provide extra layer of protection, and then you need some breaker, circuit breaker, so that you can use those point to the home appliances. And also you can send it with meter, the net meter or energy meter, whatever you want, and then that can directly, you can connect it through the grid.
It's a national grid.
That is not national grid, that is called distribution grid. Okay, because maybe if you use your home, then it should be your distribution grid, and or if it is a very big plant, then definitely you need extra layer of connection. We can say it distribution grid because our layout is not related to the very big photovoltaic power plant. You can just say it solar home system or solar rooftop PV connection, grid connected. Okay,
Okay, sir.
as we don't have any transformer type of things here, you see, only we have the inverter, and then you are sending it to the energy meter by using some circuit breaker and then connect it to the distribution grid. That energy meter or the net metering system, it should have some algorithm, okay, and that can just adjust the whole things with the distribution grid and send the energy to the grid. But if you have the very big power plant, then you require some transformer there to step up the voltage, right? So after also you should make it 3-phase, right? Here I am showing you the single phase, right? So that means for the grid, you need to convert it in a 3-phase. That means you require 3-phase converter, 3-phase AC converter, right? So that means inverter should be 3-phase. And then you are getting the 3-phase output. You need to connect it with the node. And with that node, you need some transformer, step-up transformer. Then after stepping up the voltage, you can connect it to the grid, okay? So that is, you need another layer of additional components. You understand?
Yes, sir.
Okay. So I think that's all for today's lecture. So I'm just going to recap the whole things. First of all, we are trying to cover solar power plant. So it is in two types: solar thermal based power plant, solar photovoltaic based power plant. So before that, we cover what is irradiation and difference between irradiance and the energy, which is collecting from the solar or the sun. And the irradiation has three components: direct, diffusion, and reflected irradiation. And the irradiation varies hourly, so you can get the maximum irradiation if the cloud free day you consider, then it should be at 12 o'clock. You can get the maximum power from the sun. And also you can get the cumulative energy if you consider the hour based. If you multiply the hour with the power, you will get the energy, which is called kilowatt hour per meter square, which is daily energy. And the solar thermal power plant has flat plate collectors, also the concentrating collectors. I have considered here parabolic trough, which is considered in this block diagram to draw the solar thermal based power plant block diagram. So the collected hot water can directly fed into the superheater, also in the vaporizer and preheater, and also in the reheater, okay? And after that, you can feed it again to the concentrator to get heat again. And also you can store some hot water, and also you can use that hot water when the sun is not there, okay? So that is the main concept. And also the solar photovoltaic power plant, if you consider it off grid, that means standalone, so you can draw it like that with the charge controller, battery, and some switches. If you want to use it in the AC load, you need inverter. And the grid connected rooftop PV, maybe you can use similar approaches, but no charge controller there, just only the inverter and circuit breaker, energy meter. And if you have the big type of power plant, you need to convert it into 3-phase. After getting the 3-phase AC output, you need a transformer to step up the voltage to match the required parameters with the grid, okay? So that's all for today's lecture. If you have any question, you can ask me. Otherwise, I can take the attendance. Okay, Tahmidur Rahman.
Present, sir.